All right, thank you so much for joining us today. In the previous two videos, we talked about vectors and we talked about scalars, right? So we talk about vectors and we talk about a unit vector. We talked about a position vector, and then when we talked about scalar, we talk about a scalar product or a dot product, right? And we looked at some properties of scalar product, and then we looked at when two vectors are equal to 0 and they are non-vectors or a non-vectors, then they are perpendicular to each other, right? So in this video, we are going to talk about coplanar vectors. Now, what are coplanar vectors? So now remember the idea that we said a dot b is equal to 0, and if A and B are non-vectors, then they are perpendicular to each other. Now, when we are talking about a coplanar vectors, we are saying that these two vectors are parallel to the plane, or they are on the same, or the vectors are on the same plane, right? So these are the two words that we are using here. So they are parallel to the plane, or the vectors to the plane, or the vectors on the same plane. So one is a parallel. So for example, this and this, right? Or we can say that they are on the same plane. So one is here, one is also here. Then we are saying that these two vectors are what? Coplanar, right? So like this is vector A, this is vector B. This one too can be vector A, and this one too can be vector B. So they are on the same what? Plane. The vectors are on the same plane, or they are parallel to each other on the plane, right? So we are saying that this is a coplanar. So now we are saying that, let's assume that we have um, three vectors, let's say A, B, and C, and they are coplanar to each other. Then what we can do is, now anytime three vectors are coplanar, then we can write them as a linear combination. So like for example, if we have A, B, and C, right, to be a coplanar, then we can write A to B as a linear combination. When you say a linear combination, then we can add them using a scalar. So what we can do is we can say that, okay, A is equal to, let me define some scalars, right? So let's assume that mu and let me say lambda are scalars. Then I can write A as mu B plus lambda C. I can also write B as mu A plus lambda C. And I can also write C as mu A plus lambda B, right? So it depends on how the question is going to say. If the question is saying that A is coplanar to B and C, then we write it in this form. If the question is also saying that B is coplanar to A and C, then it goes this form. If C is coplanar to A and B, then we can write it this form. So whenever we have three vectors that are coplanar, or one of them is coplanar to each other, to them, then we can write it as a linear combination. So that is what we just need to know. Now, what we just need to know is these two things here, these two words. They are on the same plane. So that's the key word that we need to learn from here. Or they are parallel to the plane. Good. So that is the coplanar, what we just need to learn from here. So now let's take some example and let's practice. So remember, we are talking about, let me just give you some words here. So we are talking about perpendicular, right? And we are saying that if you don't see perpendicular, what do you see? You will see orthogonal, right? So like kind of two different words that you need to see. That is when, and when you see these two, when you dot them, it should be equal to 0. And then we just learned coplanar, right? So coplanar is, let's say they are parallel to each other, or they can be the same on the plane. Same on the plane, or we can also have coplanar. So these are the words that you need to learn. So when I hear perpendicular or orthogonal, or if I see a parallel to each other or same plane or coplanar, then I know how I'm going to deal with them. So these are the two terms that we need to learn here. Okay. So now let's go through this example. We are having A and B. Then find the vectors, or find the vector that is perpendicular to A and coplanar to B and C. So here we want to find a vector, right? So what can we do? We need to define a vector because we don't know that particular vector. So let's C be a vector. So when I do that, C will be equal to C1I plus C2J plus C3K. Is that right? Then the first one is that vector, which is C, is perpendicular to A. And we know that if something is perpendicular, then when I dot them, I should be getting 0. Is that right? And that vector again is coplanar to A and B. So here what I need to do is I need to define a scalar, right? Because C is now the vector which is C is coplanar to A and B. So I need to define a scalar. So let's mu and lambda be a scalar such that C will be equal to mu A plus lambda B. So these are the two equations that we need to set before we can now look for that vector. So now we have this equation, we have this equation. So let's go through it. So the first one is when I dot C and A, I need to get 0. So I'm going to dot this and that, and I should be getting 0. So what is C dot A? C1I plus C2J plus C3K dot, what is A? 8I minus, no, plus 2J minus what? K. So let's do the dot product. I'll have 8C1 plus 2C2 minus C3. And this should be equal to 0. So this is like equation 1. Then equation 2 is saying that C, right? C should be equal to, what should be C equal to? Okay, C should be equal to when you do the product there. Okay. So let's do that. C is equal to mu of A plus lambda of B. Now let's put this one down and let's do something here. Now we saw that um, this A dot B here. Let me just put here A dot B. This one can be written as, now we know that C is equal to this. So let me use that technique here. So this one will be mu A plus lambda B dot A. Right? So what can we get? This is going to be mu plus lambda B dot A. Right? So this is what you are going to get at the end of the day. And remember, since A dot C dot A is equal to 0, this should be equal to 0. So we are having mu times A. Mu is a scalar, so A dot A plus lambda B dot. So let's go and look for A dot B and B dot A. Right? Let's go and look for that. Let's go and look for that. Let me just shift these guys to the left to right. Good. Let's look for A dot B. Okay. So what will be A dot B? So let's look for A dot A. A is 8i plus 2j minus k dot 8i plus 2j minus k. So let's do that. 8 times 8 will be 64, yeah, plus 2 times 2 will be 4, and the minus 1 times 1 will be plus 1. So this is going to be 69. Is that right? Let's look for a dot b. This is 8i plus 2j minus k. What is b? B is 3i minus j minus 3k. So let's multiply them. 8 times 3 is 24. 2 times minus 1 is 2, and minus 3. So this is going to give us, okay, this one should be plus, and this one should be giving us 25. So now we know a dot a and b dot b. Let's plug them in here. So this one is going to give us 69 mu plus 25 lambda should be equal to 0. So this is what you're going to get when you do the substitution. Now I can find mu. What am I going to get? This implies that mu can be written as minus 25 divided by 69 lambda. So what can we do here? Now that we know mu, we can plug it inside C, right? We can plug it inside C. So let's do that. Okay, let me just come up here, then just shift this my people to right. Now we know that good. We know that C is equal to mu A plus lambda B. Now we know mu, right? Mu is equal to what is here? Minus 25 over, so this is minus 25 over 69. Is it lambda? Yeah. Lambda A plus lambda B. So now we can now do substitution. We know A, we know B, right? So this is the same as, I can factor lambda out. So I'm going to have minus 25 over 69 A plus B. So let's do that. Let's do that. Let's do the multiplication. So this is going to be lambda out, and then I need to multiply through by, okay, well, do you know something? Let me just interchange something here, right? Let me rather make lambda the subject, so that it's going to be the same thing, but I'll just have lambda. Let me make lambda the subject so that I'll get it in this form. 69 goes up. So this is going to be, since I'm making lambda the subject, I'm going to have this plus lambda b. So this will be mu a plus, no, minus 69 over 25 b mu. Good. So that I will have rather mu out, and then have this one to be a minus 69 over 25 b. Good. So I just change, I just made lambda the subject. So when you are making lambda the subject, this will move to the right, becoming negative, then divide through by 25. Then you come and plug it inside the C here. Where is C here? Then we just get something like, so what is A? We know that A is 8i plus 2j minus k minus 69 divided by 25 times B. What is B? 3i minus j minus 3k. So this is what you're going to have. So let's simplify this, and then we are done, right? Let's simplify this and we are done. Let me have my mu here. Let's simplify this and we are done. But before I clean the board, let me just explain some things here. So what we did do when we set up the vector, we saw that c dot a is equal to 0 because c is perpendicular to a. Then we define two scalars, mu and lambda, such that c is coplanar to a and b, right? So linear combination. And what did I do? After that, I knew that c dot a is equal to 0. So now I need to plug in my c inside this. So that's what we had it here. So c dot a is equal to c is here, then I dot it with a. So when I did that, I saw that okay, I can multiply this by this because this is a scalar, this is also a scalar. This is a vector, this is a vector. So I'm going to have a dot a, b dot b, which is equal to 0. Then I need to go and look for a dot a and then b dot b. Sorry, b dot a. So I came here and then I came to do that using the dot product. Using the dot product. So when I finish this and this, then I came to do substitution here. And then I make lambda the subdet. And when I had lambda, I came back to the c. Then I came to write it in this form. So c now is equal to this. And this is what now we are doing. So we are trying to simplify this and see what we are going to get at the end of the day. So let's do that. So remember here, our final results is going to be in terms of this. If the question is asking us to find a unit vector as we did in the previous video, then you will see that this mu will cancel out because we need to go and find the magnitude and it will come and cancel out. But since we are finding just the vector, we are not going to cancel it out. So let's now do what we can do. Now, this is equal to, let's simplify. This is equal to mu 8i plus 2j minus k. Let's multiply through by minus 69 over 25 through this. So we are going to have minus 207 divided by 25i plus 69 over 25j plus 207 divided by 25k. So what can we do? Let's try and then add the same direction, same direction, same direction. So 8 plus this is going to give us minus 7 divided by 25i. Add 2 to this, and we are going to have plus 119 divided by 25j, and then plus this and this is going to give us plus 185 divided by 25k. Is that right? When I want to multiply this and this one will be 25 over 25. So subtract 25 from 207. Okay, let me just try and simplify something there. 3 times 69. This one will be 39. No, 310 is 30. So when you multiply by 9, it should be 27. Yeah. And then this one is like 16. No, 18. So okay, that is right. 207 is right there. And then when I multiply this one to okay, the same thing. So now when this one is 1, so I'm going to have like 25 minus 25 minus 207. So 207 minus 25, this one should be 2, and this one should be 18. Okay, so instead of 5, I think this one should be 2. Is that right? Yes. Yeah, that is right. So when I add 25 to this, and I get that. So that one should be 128. And then let's look at this. This is going to be 50 plus this 119. Okay. Then 8 times 25. I'm not using calculator, so I just want to confirm. This will be 0 4. This will be 16. 16. This one will be 20. So 200. 200 plus minus that should be 7. Okay. So that's right. Okay. So now what can we do? We can factor I can factor minus 7 over 25 out. So when I do that, here will be left with I. When I do that, this one will become minus, when you factor 25 out, this will be 25. 7 divides 199 how many times? Okay, let's check it out. 199 divided by 119 divided by 7 should be 17. Yeah. So this one will be 17J. Then we have 128 divided by 7. And that one's going to give us 26. So also minus 26K. Good. So this is what we are going to get at the end of the day. So this is what is going to be the vector that is perpendicular to A, but coplanar to A and B. And you see that this vector that you've got here, when you dot it with A, you are going to get 0. Yes, when you dot it to A, you need to get 0 to confirm that, yeah, this is right. This is right. Okay, so this is what you are going to get for A. Let's take another example. Then I'll give you some to try. Now you remember this word, orthogonal. It means that they are perpendicular to each other, right? So we know that since this is orthogonal, so we can start by for orthogonal vectors. For orthogonal vectors, then when I multiply A to B, A dot B, I should have 0. So that is orthogonal vector. So let's do that. A dot B should giving us 2i plus aj plus k dot 4i minus 2j minus 2k. So this is going to give us 8 minus 2a minus 2. And we know that a dot b should be 0, so we are going to have 8 minus 2a minus this to be equal to 0. So we are going to have 6 minus 2a is equal to 0. 2a is equal to 6. Divide through by 2 and getting this one to be equal to 2a. Yeah, so they are very simple. All you need to know is remember the terms and then also remember the formulas. If we're able to do that, it actually helps you to, like know some of the things that you need to do. So you see that this one I didn't waste much time because I know that if they are orthogonal to each other, then when I dot them, I should just get 0, and it helped me to find my A in the fastest way. All right. So I think I'll give this to you as a trial one for you to also do the same thing. So I did 2 examples. I'm giving you 2 examples. So the same thing. Determine the value of x such that A and B are perpendicular, like the way I did this one, orthogonal, right? Then you find for x. Then the same thing to the first example that we did here, right? This one too, I've given you A and B, and then you are going to find a vector that is perpendicular to A and coplanar to A and B. So same procedure that you need to go through so that you get the concept. You can practice with something. Right. So when you finish, don't forget to drop your final results in the comment section so that I can check it for you if you had it right or not. All right, see you in the next video.